5816. To stop a ground loop to the left after landing a glider, it would be best to lower the A. Right wing in order to shift the CG. B. Left wing to compensate for crosswind. C. Nose skid to the ground and apply will brake. The correct answer is C. When the glider begins to swerve, the nose skid is useful until it may dig in and cause the glider to twist into a ground loop. Locking the wheel once the swerve has begun will help. Apply heavy pressure on the brakes. 5817. In which situation is hazardous stall more likely to occur if inadequate airspeed allowance is made for wind velocity gradient? A. During the approach to a landing. B. While thermal ling at high altitudes. C. During takeoff and climb while on aeroto. The correct answer is A. Inadequate airspeed allowance for wind velocity gradient can increase the likelihood of a hazardous stall, particularly during the approach to a landing. Wind velocity gradient refers to the change in wind speed with altitude. It can create variations in the effective airspeed experienced by the aircraft at different altitudes. If a pilot does not adequately account for this gradient and fails to maintain an appropriate airspeed, it can lead to a dangerous situation. During the approach to a landing, when the aircraft is descending and encountering different wind speeds at various altitudes, the risk of a hazardous stall increases if the airspeed is not properly adjusted. Inadequate airspeed allowance for the wind velocity gradient can result in a sudden decrease in airspeed, increasing the angle of attack and potentially leading to a stall close to the ground, which can be particularly dangerous. 5818. With regard to two or more gliders flying in the same thermal, which is true? A. All turns should be to the right. B. Turns should be in the same direction as the highest glider. C. Turns should be made in the same direction as the first glider to enter the thermal. The correct answer is C. When multiple gliders are flying in the same thermal, the general rule is that turns should be made in the same direction as the first glider to enter the thermal. By following this convention, all gliders in the thermal will be turning in a consistent direction, which helps to maintain orderly and predictable flight patterns. It reduces the risk of collisions and improves overall safety. 5819. Which is true regarding the direction in which turns should be made during slope soaring? A. All reversing turns should be made to the left. B. All reversing turns should be made into the wind away from the slope. C. The upwind turn should be made to the left. The downwind turn should be made to the right. The correct answer is B. Regarding the direction in which turns should be made during slope soaring, it is generally true that all reversing turns should be made into the wind, away from the slope. Slope soaring involves utilizing the wind that is deflected upward by a slope or ridge to gain lift and maintain flight. When making reversing turns, it is essential to maximize the lift provided by the slope. By making turns into the wind, the glider maintains better airflow over the wings, allowing for more lift and control. Turning into the wind helps to maintain a closer alignment with the slope, reducing the risk of losing lift and potentially encountering a loss of control. 5820. Which airspeed should be used when circling within a thermal? A. Best L/D speed. B. Maneuvering speed. C. Minimum sink speed for the angle of bank. The correct answer is C. When circling within a thermal, the airspeed that should be used is the minimum sink speed appropriate for the angle of bank. The minimum sink speed is the airspeed at which the glider achieves the lowest rate of descent in still air. When circling within a thermal, the goal is to maximize lift and stay within the rising air. Flying at the minimum sink speed allows the glider to maintain the best climb rate in the thermal. The appropriate angle of bank for circling in a thermal can vary depending on the specific glider and conditions. It is generally recommended to use a bank angle that provides a good balance between maintaining a tight turning radius and avoiding excessive drag.